Today we're going to talk about human population dynamics. Our goal is to explain how human populations experience growth and decline. And in order to accomplish our goal, we're going to explain the carrying capacity for humans, or if there is a carrying capacity for humans. We're going to describe the factors that affect human population growth and describe the rule of 70. So the question is, are there limits to human population growth? Here we can see a human population growth curve, that the population was very low for very long, and then in about the 1850s to the late 1800s, we saw a drastic increase in human populations. This is Thomas Malthus, who came up with the Malthusian theory about human population growth. He theorized in 1798 that human population growth was exponential, that it would just keep going forever. However, our resources were linear, and we would eventually hit a point where we could not make more food or provide more resources for the population, even though the population could continue to grow. So, what exactly does affect whether a population is growing or declining? Several factors. We could have simple birth and death rates. So the number of births, your rate of infant mortality, and your death rate. We also see the access to family planning. So if there are ways for couples to access family planning, that's been shown to reduce the overall numbers of offspring. We have access to good nutrition. So this is going to impact that infant mortality rate and how long infants and young children can survive. We have access to education. As we learned previously, educating females shows later age at first birth, which will decrease our overall birth rates. And lastly, we have the postponement of marriage. So waiting until you're older to get married tends to correlate with having fewer children. But we also have density dependent and density independent factors. So these are things that control the population. The density independent are things that do not depend on the number of people there are. These would be things like natural disasters such as a hurricane. Hurricanes hit certain areas because of climate and geography and not because there's people that live there. Things like fires. Those happen because they're a natural part of the ecosystem. And drought. Drought can go either way, but for the most part, some areas exhibit a drought because of a change in the climate patterns. We also see things that are density dependent, and these things do depend on the number of people that reside in a certain area. So this would be food and water availability. When you have more people, you have less food and water available. More people, more close together, we have higher rates of disease, and the amount of territory available decreases with an increase in density. We can measure the way that populations are growing by using what's called the rule of 70. So there's several different pieces of population math. Before I get into the rule of 70, we can track population changes by the births and immigrations, which is the people coming in, and the deaths and emigration. This is the people going out. We can look at the crude birth rate, which is the number of live births per 100,000 people per year. The crude death rate, which is the number of deaths per 100,000 per year. And again, this doubling time of the population, the 70% rule. So the rule of 70 has us divide the number 70 by the percent population growth rate, which gives us a population's doubling time. This would be the length of time it will take for the current population to double. So if we take 70, we divide that by the percentage population growth, that's R%, we're going to get the doubling time. So let's look at an example. If we look at the US with an R, a growth rate of 0.7%, if we take 70 divided by 0.7, That's going to give us 100 years. In 100 years, the population that exists today in the United States will have doubled. To give another example, if we had the current population of the world, which is 7.6 billion, 7.6 billion, we have a current R percent of 1. This makes our math pretty easy. It means we just take 70, divide by 1, and then we know it'll take 70 years for the current world population to double to about almost 15 billion people. So to summarize what we've seen so far, our goal was to explain how human populations experience growth and decline. We discovered that populations grow or decline because of several factors such as birth rates, infant mortality rates, death rates, family planning, postponement of marriage. They can be impacted by density-dependent and density-independent factors. And then we saw that the rule of 70 tells us how long it will take for a population to double its current population.